Welcome back to The Explainer. Today, we're unpacking something absolutely fundamental about artificial intelligence. A lot of people think machine learning is just this one giant mysterious brain that does everything the exact same way. But it's really not a monolith at all. Instead, it's a diverse, highly specific toolkit designed to solve very particular types of problems. And we're going to break down exactly how that works by looking at the three distinct flavors of machine learning.
Now, to really understand these machines, I want you to think about how we humans learn. First, imagine a math student sitting at a desk, carefully having every single homework problem corrected by a teacher. Okay, now picture a shopper wandering around a brand new mall, naturally noticing that, hey, all the shoe stores seem to be clustered on the second floor, without anyone explicitly telling them. Finally, think of a toddler learning to walk, falling down, adjusting their balance, and trying again until it finally clicks. Well, as it turns out, machine learning matches these three human approaches perfectly.
So here's our roadmap for today. 1. How humans and machines learn. 2. Supervised learning. 3. Unsupervised learning. 4. Reinforcement learning. And 5. Busting the AI myth.
Let's dive right into Section 1, how humans and machines learn.
Machine learning really boils down to these three distinct flavors: supervised learning, unsupervised learning, and reinforcement learning. Whenever you interact with AI out there in the real world, whether it's recommending a movie or filtering your inbox, it is using one of these specific approaches, or sometimes a clever combination of them, to get the job done.
Moving on to Section 2, Supervised Learning, which is our guided student.
Supervised learning is essentially learning with the teacher. The system is given data that is already labeled with the correct answer. The machine isn't just guessing in the dark here, it's studying a massive, pre-filled answer key. I really want to emphasize this because of the three flavors we're looking at today, this is by far the most common type of machine learning you interact with every day. So, the absolutely crucial concept here is the label. A label is simply the correct answer attached to a piece of training data. Just like a math teacher writing a big red A+ or an X next to an equation to show the student what's right and wrong, the label tells the machine exactly what it's looking at so it can study that pattern and apply it later.
This brilliantly illustrates how it works in practice. On one hand, you've got the human student learning math through meticulous correction. On the machine side, you have your everyday email spam filter. To build that filter, programmers feed the AI thousands of emails that are already pre-tagged with labels reading spam or not spam. The AI studies those labeled pairs, figures out the common traits of junk mail, and then takes what it learned to predict the labels for brand new emails hitting your inbox today.
Right, let's jump to Section 3, Unsupervised Learning, Finding Hidden Patterns.
Now, unlike our last example, unsupervised learning happens entirely without a teacher. There are absolutely no labels here, no predefined correct answers whatsoever to guide the system. The machine is learning by noticing patterns alone, using purely raw data. It's basically just dropped into a sea of information and told, hey, figure out how this is organized. A real game-changer concept here is clustering. Clustering is when the AI groups similar data points together without any predefined categories. Actually, scratch that. It's more like the AI builds the categories itself. For example, if an AI is studying thousands of customer purchase receipts, it might notice entirely on its own that buyers naturally fall into distinct groups, like bargain hunters, luxury buyers, or occasional shoppers. No human programmer told the AI those categories existed, it just found the natural clusters within that raw data.
Just as a shopper naturally recognizes store layouts without looking at a mall map, unsupervised learning is exactly what happens when a streaming platform groups its viewers. It studies viewing habits and naturally clusters users into types, weekend sci-fi bingers or people who only watch short comedies. It does this entirely on its own, without anyone explicitly setting up those distinct categories in advance.
Section 4, Reinforcement Learning, or Trial and Error.
Reinforcement learning is literally learning by trial, error, and reward. In this scenario, the system takes actions and receives continuous feedback. It absolutely requires an environment where its actions result in either a clear reward for a good outcome or a penalty for a bad one. Let's look at how this builds into a trial and error loop. Step 1. Take an action in an environment. Step 2. Receive a reward or penalty. Step 3. Adjust the strategy to get better rewards next time. This exact three-step method is how AI taught itself to play unbelievably complex games like chess and Go at superhuman levels. Nobody told the AI the right moves. No way. Instead, it played millions of games against itself,
receiving a penalty for losing and a reward for winning, gradually favoring only the moves that led to victory.
This is a super active way of learning. Just like a toddler constantly adjusting their balance after a fall to finally take those first steps, a robot vacuum navigates your living room using reinforcement learning. It learns its most efficient path through repeated attempts. Every single time it bumps into your coffee table, it gets a small digital penalty. Over time, it adjusts its route to maximize its rewards and clean your room perfectly without hitting the furniture.
And that brings us to Section 5, Busting the AI Myth.
Okay, let's dismantle a massive misconception right now. The myth? All AI works the same way under the hood. That is entirely false. The reality is that these three approaches, supervised, unsupervised, and reinforcement, are fundamentally different. They require completely different types of data, and they are engineered to solve entirely different problems. AI is for sure not one uniform monolithic technology.
Because they're so different, choosing the right machine learning flavor is essential for success. If you try to use the wrong model for a problem, it's exactly like trying to teach someone how to swim using only a classroom lecture. It's a completely mismatched approach that will guarantee poor results. I mean, you wouldn't use labeled spam email data to teach a robot vacuum how to navigate a room. The tool just has to match the task.
So, to solidify everything we've just covered, let's do a really quick recap. We have supervised learning, which relies on labeled data, just like your email spam filter. Then we've got unsupervised learning, tackling unlabeled data to find hidden groupings, much like a streaming platform organizing its viewers. And finally, reinforcement learning, which uses a trial and error approach based on rewards, perfectly demonstrated by our robot vacuum.
As we wrap up this explainer, I want to leave you with a question to chew on. Which of these three flavors do you think powers the recommended for use section on your favorite shopping or streaming app? Think about the data they have, how they group things, and what they're actually trying to predict. Thank you so much for joining me on the explainer today, and keep looking for those distinct flavors in the technology you use every single day.